right, here's number 66, and hopefully I can get through the rest of them in this period, right? So we have a local equilateral triangle. It means that all these angles are the same, and all these line segments are the same, and the height of this triangle, we're going to use this as orange, I guess. The height is 10 units. Okay, what is the perimeter of this logo? All right, so each one of these angles here, we're going to use blue. Each one of these angles is there's 180 degrees, 180 degrees in a triangle, and there's 3 of them that are all equal. So there's each one of those angles is 60 degrees. Each one of these blue angles here is 60 degrees. Okay, one of these angles, this one here, namely, is cut into 2. Even one bisected by this, so it equals 30 degrees. This one's 30 degrees, and this one is 30 degrees. Right, so right here, this is a 90-degree drop, so this is a 30, 60, 90 triangle, both of them, and it bisects this line and this line. Okay, so I have here, each one of this line segment here is a hypotenuse, and this line segment here is a hypotenuse of the 30, 60, 90 triangle. These legs, this is a short leg, this is the short leg, this is the long leg, and this is the hypotenuse. Either way, you can do some trigonometry here, or you can do this is the square root. This is 2, the short leg, this is the short leg, and this is the square root of 3, the short leg. You could do some math, or I'm just going to do the trigonometry because I think that's going to be a little easier. All right, so you can figure out using, well, we can do either the blue angle or this angle here. I'm going to use the blue angle, right? So using the blue angle here is my theta at 60 degrees. I'm going to say that the opposite, I'm going to be using opposite and hypotenuse. So that's going to be the sine. The sine of the blue angle of 60 degrees equals 10 over the hypotenuse. Right, so to make the hypotenuse longer, right, or to algebraically solve for this, I'm going to say the hypotenuse equals 10 divided by the sine of 60 equals, well, I'm just going to go with the calculator, 10 divided by 60 sine equals 11.54. That's going to be, so make it 11.55. Right, I should make that equal to this, 11.55, right? So that's 11.55. 11.55 times 3 equals 34.65, and that is the perimeter of my logo. Okay, so we have which this following statements are not valid. So select all that apply. Okay, all quadrilaterals have 4 right angles. That's not true. All right, so that is not true. It's false. Select all the false ones. False. If that was true, then all quadrilaterals would only be squares and rectangles. A triangle is a polygon with 3 sides. Did I skip this side? I did. I'm going out of order. So 67. I already went over this one. I already went over this stuff. 60, no, I didn't. Okay, 67. Oh, no, I'm not going in order. Okay, so 67. A polygon is a triangle with a triangle is a polygon with 3 sides. That is true. All circles are similar. That is true. All equal angular quadrilaterals are congruent. That is true. And then a trapezoid must have at least one obtuse angle. That is also true. Actually, I'm going to revisit this one. All equilateral quadrilaterals are congruent. That's actually false. That's actually false. Because you can have different lengths. You can have different lengths that are not congruent, right? They can be completely different, like lengths that are not proportional, but the angles could be the same. So this is false. So anyway, all right, so then we have this one here, and we have that angle A, angle B is a right angle, and we got to figure out angle AB, line segment AB is 1.5, angle, this BC is 3.1, what is angle C, and angle A. And we also later on asked the length of AC. What is AC? Well, AC is easy. It is the square root of 3.1 squared plus 1.5 squared, because Pythagorean's theorem. Just do that right now. 3.1 squared plus 1.5 squared equals, take the square root of that, and that's equals 3.44 equals 3.44 approximately. All right, so there's that one. So then we're going to do, so the angle C. Angle C is opposite the short leg, so it's going to be an angle less than 45 degrees, so we know it's going to be the tangent. We're going to use the tangent of opposite over adjacent. So this is going to be the arctangent. We're using an arctangent. So the arctangent, so angle C equals the arctangent of the opposite, 1.5, divided by the adjacent, 3.1. And then angle A equals the arctangent, sorry about that, the arctangent of 3.1 over 1.5. It's going to be the reciprocal of that because it's opposite over adjacent, and that's going to be bigger than 1, that's going to be less than 1, right? It's going to be, this is going to be less than 1, this will be bigger than 1. That makes sense because the angle bigger than 45 is going to have an angle, is going to have a tangent greater than 1, and vice versa. All right, so here we go. This is going to be equal to, this is going to be equal to, so we have 1.5. This is not negative 1.5. This is the arctangent. That's the arctangent, right? So let me maybe put this in parentheses to not confuse it. All right, so it's going to be 1.5 divided by 3.1, okay, equals, and then you take the second arctangent, and this is 25.8. This is 25.8 degrees. And you do 3.1 divided by 1.5 equals, and then you take the arctangent, 3.1 divided by 1.5 equals, and you take the arctangent of that, and it's 64.2. And if you take 64.2 and add to the 25.8, you get 90 degrees. And there you go, that's that. That's everything for 68. All right, 69. Okay, so let's identify a P and a Q statement here so we can figure out all the different things. Our P statement will be, I can run in under 5 minutes. And then our Q statement will be, I can start in the front of the race. So this is our Q, and this is our P. This is our P. Okay, so let's find our inverse. So it's going to be positive. It's going to be like these two just swapped. Okay, I can run in a 5K race. So that's, here we go. I can run. I cannot. Nope, see, that's a cannot and a cannot. I can run, and I can. Okay, so there we go. So this is our can. There's our Q, and there's our can. All right, so there we go. That is our inverse statement. This is our inverse. Because it just flipped the two, right? But it didn't make them contrary. It didn't say it did not. A converse is when they say it's the same thing as these, right? But it says I cannot, right? So I mean, cannot run a 5K. Okay, I can start, that's not it. It cannot run a 5K, and I cannot start. So this is P naught, and this is Q naught, right? So this is P naught and Q naught, and this is the converse. That's the converse. This should be red, actually. This should be converse. Or, sorry, this should be inverse. And this should be still blue, but converse. Converse, because it starts with the P. Converse. Actually, I was right there. They are backwards. This should be the inverse, excuse me, because I'm adding not. Inverse adds not. And then the converse is the same, but it just switches them. Same, just switch. Just switch. It's this is the converse. Okay, all right. So then we're going to try to find, see if and then we're going to try to find the contrapositive. Okay, so let's see if we can find a contrapositive. So that's going to be the switch of the inverse. Okay, so it's going to be the switch of the inverse. So it's going to be I cannot run at the front of the race. So then I cannot. So yeah, here we go. Wait a minute. So it's going to be I cannot. Okay, so it's going to be the inverse. I cannot start the run on. Okay, so that's the Q naught. And then here's the P naught. There we go. That's the P naught. P naught. Okay, so we found the converse, found the inverse, and we found the contrapositive. Okay, so this is the Q naught, and this is the P naught. This is the contrapositive. Contrapositive. Okay, so here we go. Just to recap all that stuff, right? Your P and your Q is the initial statement. The converse, they just swap the Q and the P. The P swap. The inverse, the Q, the P and the Q are in the same spot. P and the Q are in the same spot, but they're knots. Right? The contrapositives. Contrapositive, the Q and the P are swapped, and they are knots. So that's kind of like that's how they are right there. Okay, so that's how all the different relationships are. All right, moving on to 70. All right, so number 70, we have an industrial chain has 4 congruent gears. Find the approximate length of each gear. All right, so let's kind of like see what we got going on here. Let's use green. So we have this is a radius, this is a radius, that's a radius, and that's a radius. And then going this way, we have the same thing. We have a radius going that way, a radius here, a radius here, and a radius here. Okay, so going the whole way here, going this way, we have 4 radii. Going this way, we have 4 radii. There's 4 radii going that way. So it's going to go that way. Now we got 4 radii going this way. Actually, from here to here we have 2 radii. 2 radii. From here to here we have 2 radii. From here to here we have 2 radii. From here to here we have 2 radii. So altogether, from here to here we have 4 radii. And then we have 4 corners here. So the 4 corners are going to count for 90 degrees. So 90 degrees is going to count for a quarter of a radii. Yep. So because 80 degrees is 1 radii. Right, so you have 4 times 1/4 radii. Okay, so you have 2, 4, 6, 8 radii there. So you have 8 radii plus 1 radii equals 9 radii. Actually, I'm going to step back a little bit, and each one of these circles here is going to count for a 1 whole circle. Is going to account for, so it's going to account for 2 pi r, right? Because I have 4. Is going to account for a whole circumference, because I got 4 to the circumference, right? So that's a circumference. That's a quarter of a circumference. That's a quarter of a circumference. This is 2 pi r divided by 4, right? So this is 2 pi r divided by 4. 2 pi r divided by 4. This is 2 pi r divided by 4. Okay, so that makes more sense, I think. So I got 8 of these, and then plus 2 pi r divided by 4. All right, so now I'm going to plug in 8 times 68 centimeters plus 2 times pi times 68 divided by 4. So it's going to be 8 times 68 equals 544 centimeters plus, and this will be just 2 times pi times 68 equals, divide that by 4 equals plus 106.8 centimeters. This is the length. This is the length. This is the length equals, so that's going to be 544 plus 106.8 equals 650.8 centimeters. Let me look this over and see if I made any mistakes. I did make a mistake. This was 2 pi 4 times 4. So this should just be 2, that should cancel out. So it's just going to be 2 pi times 4. All right, so this is going to be this will erase, and that term is going to change to something different, and that's going to make that different. Okay, so times 4, so it's going to be 2 pi r. So this is just going to become 2 pi r. 2 pi r is just going to be the radius, or just the circumference of one circle. All right, so it's going to be, again, 544, and then times 2 times pi times 68, which is equals 427.3. So 427.3 plus 544, 971.3 centimeters. So there we go. Let me check the key real quick. They got 971.312. They rounded it to that. Okay, so there you go. That's that one. Okay, in the center, in the circle, the radius 7 has an arc. An arc has a length of 8. What is the area of the sector? Okay, so let's draw a quick little circle here at the center, and then that center will have just a little circle here. Quick little circle. Its radius is 7. And has an arc length of 8 meters. Okay, so what is the area of the sector? Okay, so we know that, I have to focus that a little. All right, so we know that arc length of the arc equals pi r, 2 pi r times theta over 360. Okay, they didn't give us 360 or anything like that, but we can, it's a kind of a ratio thing here. So we know that this is 8, this is 8 meters, and we can figure out it's like a ratio here. Okay, so now we'll just plug in what we know. So this is going to be 8 meters equals 2 pi r over 360, right? So I'm gonna factor out the 8 meters equals 2 pi r over, this is gonna be just this over 360, because I don't know this, right? And it's gonna be equal to, so I'm just gonna divide both sides by 2 here. So it's gonna be 4 meters equals pi r times this over 360, because this is my unknown here. Okay, so what can I do with that? And I know that my area equals pi r squared times this, and I can change that into pi times r times that. So this, let me rearrange that. Area equals r times pi times r times this. So this and this are the same. Oh man, ain't that some fancy math? All right, so this and this are the same here. So I can substitute this for that, I think. So let's see what happens if I do that. So area equals the radius times 4m, which is, I guess it's just 4 meters, yeah. So the area is going to be equal to the radius, which is 7 meters. 7 meters times 4 meters. Meters work out. So 7 times 4, 4 times 7 equals 28. Area equals 28 meters, question mark. What does the key say? Oh, it's just in units. But yeah, but that is what works. Holy cow. All right. So yeah, that is the correct answer. A little bit of creative substitution. That's how you get that one. And number 72. A circular man-made island. Perfect and circular. Can you imagine that? Perfect is a circular man-made island. Green. Circular man-made island has a population of about 17,281 people. A population density of 220 people per square mile. Find the radius. Find the radius of the island. Okay, so I just need to figure out what the area of the island is. Okay. All right, so we know it's people. So it's 7,000. I need miles. I need the people on top. So it's need miles on top. So I need square miles. 220 people per square mile. All right, so I need to do 17,281 people. My peoples cancel out. So I'm going to be equal to 17281 divided by 220 equals 78.55 square miles. The area of a circle equals pi r squared. All right, so to find this, I need to do the area of the circle divided by pi and take the square root equals the radius. So the radius is going to be equal to 78.55 miles divided by pi. Divide that by pi equals, take the square root, take the square root, its radius equals 5 miles. There we go, the radius is 5 miles. Okay, and finally, the last one, find the area of the park. So I'm going to have a trapezoid here and a rectangle. That's the way I'm going to do this one, I think. Okay, so this is a rectangle and a trapezoid. So 78 plus 134 equals 212. Okay, this is 70 feet, and this is 16 feet. And I have 44 feet, and then this is 48 square. This is 48 feet. All right, so let's get to work on this one. 16 times 70